An electrical storm, one of our atmosphere's most dramatic weather events. They've ravaged our skies for billions of years. But one event in 1937 revealed just how deadly they can be. An electric storm annihilated man's largest aviation achievement in seconds. The weather created a catastrophe that would change international air travel forever and go down in history as the Hindenburg disaster. Around the world and throughout time, weather has played a part in the fortunes of mankind. Violent events in our planet's atmosphere have transformed history. These are the stories of weather that changed the world.
With no hint of impending tragedy, Captain Frust brings the Hindenburg over the airport at dusk. Then, without an instant's warning, the giant Hindenburg goes to her doom.
All sides of me were just enveloped in a huge ball of fire.
I saw the wounded coming out of the ship. I saw the burned figures.
This twisted metal is all that remained when the Hindenburg, the largest airship ever to take to the skies, exploded. 36 people lost their lives.
The Hindenburg was the height of the airship era, but it was also the death of the airship era. It was the greatest passenger airship, but also the last.
The Hindenburg burned in just 34 seconds. Investigators set out to find the culprit. Their conclusion: the weather was to blame. But it's only now that we can fully understand the freak sequence of events. In the 1920s and 30s, airships were the fastest, most advanced form of long-distance luxury travel. Germany's Zeppelin company was the world-leading airship builder. Hindenburg was the pride of their fleet. Its 800-foot-long duralumin frame was braced with steel wires. It supported 16 gas chambers containing 7 million cubic feet of hydrogen. Hindenburg's hangar in New Jersey still stands.
I am always amazed at how big this building is. It is over 800 feet long on the inside, but that is what was required to dock an airship the size of the Hindenburg. And when it was inside this building, it cleared the doors by only inches.
It's a reminder of a once booming industry, destroyed by the Hindenburg disaster. May 3rd, 1937. Hindenburg emerges from its hangar in Frankfurt, Germany, ready for the first transatlantic flight of the season. Among the crew is 14-year-old cabin boy Werner Franz.
With the buoyant force of the gas, the ship just ascended into the air like an elevator. It didn't feel like we were going up. It felt like the ground just disappeared underneath us.
The Hindenburg's route takes it over France and out across the Atlantic, heading for landfall at Lakehurst, New Jersey. Passengers relax in luxury as Europe fades into the distance.
The airships were incredibly luxurious. They had staterooms with cabins, they had lounges, they had restaurants, they had a smoking room on the Hindenburg. So it was an incredibly luxurious way to cross the Atlantic.
It's fast, too.
Well, the Hindenburg was the Concorde of its day, and it crossed the Atlantic in half the time of an ocean liner. Ocean liners in the 1930s took 5 to 6 days to cross the Atlantic. The Hindenburg did it in 2 to 2.5 days.
German passenger airships had an exemplary safety record. They flew tens of thousands of passengers for over 27 years without a single injury. But their luck was about to change. They hadn't planned for the weather. Meteorologist Eric Fisher has studied the role of the weather that fateful day.
They knew that if just the right number of factors came together, maybe something bad could happen. And unfortunately, those factors did come together when it crossed the beach here in New Jersey.
Hindenburg encounters its first problem with the weather as it flies out over the Atlantic. There's a strong westerly headwind. Just as headwinds mean longer flights today, the same was true in the 30s for Hindenburg. The airship is scheduled to reach Lakehurst, New Jersey at 6 a.m. Already it's running 9 hours late. Captain Max Pruss is an expert airship captain, but there's nothing he can do about the wind.
We must try and make up the time.
I've never encountered headwinds as strong as this.
While Pruss battles the wind across the Atlantic, bigger problems lie in store at the landing site. A cold front is sweeping east across America and heading straight for New Jersey. The wall of cold, dense air undercuts warm, moist air in its path like a wedge. It forces the warm air up into the atmosphere. That spells trouble.
If you have a cold front moving in, you've got showers, probably some thunderstorms, and if you're an airship and you're flying right toward it, you're gonna have some serious problems on your hands.
As the cold front pushes over Lakehurst, thunderstorms break out. Hindenburg edges closer. Lakehurst Control radios the crew to update them.
Conditions unsettled. Recommend delay landing until word from station. Advise your decision.
Inform Lakehurst that we will wait until they tell us conditions have improved.
Pruss takes Hindenburg south along the coast to wait out the storm. Conditions are bad, but the crew are unconcerned. Dealing with adverse weather is part of the job. Pressure on Pruss is mounting. Already the flight has taken longer than planned. Now it looks like they'll have to delay the return flight too. That could be a disaster. The return flight is fully booked with wealthy Americans planning to attend the coronation of King George in England. When Pruss gets the message he's been waiting for, it's a relief.
The storm is passing. We'll be done by 6 or soon after.
Finally, the journey is over. The crew prepare for landing. But the weather is still against them. Pruss steers Hindenburg ever closer to its mooring mast, unaware that the passing storm has a sting in its tail. It's 6 p.m. on May 6, 1937. The weather is about to extinguish 36 lives and change aviation history forever. May 6, 1937. The airship Hindenburg arrives late in America from Germany. It's battled headwinds right across the Atlantic.
The original flight plan for the Hindenburg was to arrive early in the morning. It's usually a nice quiet time, a time where maybe people go for a walk, no wind. But with the delay, they're coming in late afternoon, early evening. That is prime time for thunderstorms because you've had the whole day to heat the ground and air wants to rise, especially ahead of a cold front.
A cold front has swept a band of electrical storms over the landing station in Lakehurst, New Jersey. The national press and the ground crew have been waiting in the rain for nearly 4 hours. Bob Buchanan, just 17 at the time, still recalls that day.
We got there at 3 o'clock, and it didn't come in until about, 15 minutes after 7, so that's a long wait. Yeah, we were getting bored to death, you know.
By 6 p.m., the worst of the storm has passed. At last, the delayed Hindenburg appears above the Lakehurst airfield. The ground crew move into position, ready to anchor the ship.
People can't possibly imagine how big this thing was. It was almost the length of 3 football fields.
Crowds of friends and family have gathered to witness the ship's first landing of the season. News reporter Herb Morrison is recording the event.
We're greeting you now from the Naval Air Base at Lakehurst, New Jersey, from which point we're going to bring you a description of the landing of the mammoth airship Hindenburg.
Captain Pruce lines the ship up into the easterly wind, but the wind is still unsettled.
If you're a pilot, the safest way to land your ship is going to be nice, stable wind, fly directly into it, you've got a safe landing. But if you've got a thunderstorm around, you've got a cold front moving in, you're going to have chaotic winds that could change quickly. And that's exactly what happened to the Hindenburg.
The wind suddenly changes direction, shifting from east to southwest. Even modern aircraft have problems with crosswinds when landing. Airships are even more vulnerable.
This is just a model on a much smaller scale than the Hindenburg, but when it comes to the wind, it's going to be impacted in a very similar way. Inside this restaurant, there's no wind. It's pretty easy to steer the airship. But if we were going to introduce a little bit of wind, it would become much more difficult. Even a 5-mile-per-hour wind, and this is blown off course. It's a much smaller model. The Hindenburg was a much larger airship, but it also encountered much stronger winds, and the impact would have been very much the same.
With the change in wind direction, Captain Proust must realign the airship to head back into the wind. He has 2 options: circle all the way around the airfield and lose valuable time, or land immediately by making 2 sharp turns. And that's what he does. He dramatically swerves Hindenburg back into the wind. The airship's delicate frame is not designed for sharp maneuvers. It contains over 40 miles of steel bracing wires. Pruce's sharp turns cause a bracing wire to snap. The wire whiplashes back and slashes open one of the ship's 16 hydrogen cells. Hindenburg continues on toward its mooring mast. The only signs of a problem are that the ship's skin is fluttering and the rear of the craft seems a little heavy. Pruce dumps ballast water to compensate. He and the crowd below are totally unaware that leaking hydrogen has turned the airship into a flying bomb. All that now stands between Hindenburg and disaster is a spark. As the airship Hindenburg approaches its New Jersey mooring mast on May 6, 1937, Captain Max Pruce is unaware that violent winds have turned his craft into a lethal bomb. A snapped wire has slashed open one of the 16 bags of ultra-flammable hydrogen. A single spark is all it will take for Hindenburg to go up in flames. To understand where that critical spark came from, meteorologist Eric Fisher is taking to the skies.
Well, up here, over 100 feet up into the air, we're surrounded by protons, electrons, neutrons, all those charges that are always around us every day.
These static charges create an electric field in the atmosphere, which can be measured with an electric field mill.
Right now, we've got an electric field of about 30 volts per meter, which is about the same as 10 volts per foot. In a thunderstorm, that's going to increase thousands of times, creating a huge electric field.
Most dramatically, that field causes lightning strikes, but that wasn't the fate of Hindenburg. Before landing, the airship spent almost 4 hours flying through highly charged storm clouds.
As objects move through the atmosphere, like the balloon that we're in right now, they pick up an electrical charge. That's just through friction. Something like the Hindenburg through an electrical storm would have picked up a very large electrical field.
As Hindenburg flies through the thundery skies of Lakehurst, friction against the surrounding air transfers electrons from the atmosphere onto the airship, giving its surface a huge static electrical charge. At altitude, the ship's skin and metal frame are at the same level of charge and therefore safe. That's about to change. At 7:21, the mooring lines drop to the ground. Now the weather plays its final card. It rains. Experts have pieced together what they believe happened in the next few moments. The mooring lines are now wet. That means they conduct electricity. The airship's interior metal frame is grounded. But the skin, made of less conductive linen and cotton, remains highly charged. The huge difference in voltage between the skin and the metal frame leads to disaster. A spark jumps between them, igniting the hydrogen that's been leaking from the ruptured gas cell.
All sides of me were just enveloped in a huge ball of fire.
I saw flames in the stern. It was clear the ship was lost. I needed to find a way out.
Is it really possible for one tiny spark to create such devastation? A team of explosive engineers are about to find out.
This is a model of the Hindenburg. It's the rear third of it. We've produced this from a steel laser cut frame and skinned it in a non-flammable aerospace skin to as closely represent the actual Hindenburg itself.
They connect an earth cable to the metal frame, mimicking the role of the Hindenburg mooring ropes. The cable will conduct electric charge away from the model's steel frame, but not from the less conducting skin. Their unique experiment is about to recreate the disaster. The Hindenburg disaster was caused by a series of misfortunes with the weather. Investigations have shown the most likely cause was an electric spark, jumping between the airship's electrified skin and its grounded metal frame, igniting leaked hydrogen. To discover how this is possible, a team of explosive engineers are recreating the event on a smaller scale.
This is our high voltage spark generator, creating about 50,000 volts.
The team need to create a spark between the outer skin and the grounded metal frame. After several tests, the spark generator is reliably doing the job. It's time to fill the bag of hydrogen and install it in the frame. A small cut in the bag reproduces conditions on the Hindenburg, allowing the gas to slowly leak out.
Okay, we're set to go.
Okay, Deacon, we're standing by on the box.
Okay, Dave.
3, 2, 1.
One tiny spark is enough to turn the hydrogen leak into a fireball. It reveals just how easily a small electrical discharge could have triggered one of the greatest disasters in history.
This Charlie, it's firing, it's crashing, Terry, oh my, get out of the way, please! Oh, these people running and all the passengers screaming around it.
The Hindenburg burned for just 34 seconds. Amazingly, most of the deaths came from people jumping out of the ship, not from the flames. It was the worst aviation disaster the world had seen.
If the Hindenburg isn't slowed down by headwinds over the North Atlantic, they're not rushing, no problems. If hydrogen doesn't leak, there are no problems. If there are no thunderstorms, there are no problems. If it arrives on a completely dry day, no problems. But all these things happened in sequence, and that led to the ultimate problem and disaster for the Hindenburg.
36 people died, and the future of airship aviation died with them.
The crash of the Hindenburg was the end of the golden era of airship travel.
This plaque marks the spot where Hindenburg met its end. But its legacy lives on. The disaster inspired research into how electrical storms can affect aircraft. Modern planes are now fitted with static discharge wicks, which prevent hazardous charges building up. But the danger is still out there. The weather brings down on average 435 aircraft around the world each year. It's a reminder that we are always at the mercy of the world's most powerful weather events.